In this lesson, you will learn about ratios and proportions. Okay, so writing ratios. There are 3 ways to write a ratio. So in tennis class, Mark won 15 games and lost 12. Okay, so we want to represent this ratio. So we want to know that the number of wins to the number of losses. Okay, so Mark won 15. So 15 has to be first. Then here are the 3 ways. You can use a semicolon, and 12 is the number of losses. Okay, you may also write it using the words 15 to 12, or you may write it as a fraction, 15 over 12. Okay, order does matter here. Okay, let's try number 2. The number of wins to the total games played. Okay, so wins are 15. And total games, I'm going to add them up to figure out the total games, which will give me 27. Okay, I can also write it using a semicolon and using words, 15 to 27. Okay, the last one, the number of losses to the total games. So if I look up here at losses, I have 12. And I know that the total games are 27 because the wins and losses combined. So 15, I'm sorry, this is 12. Losses to total games and losses to total games. Okay, so here are the 3 ways that you can write a ratio. All right, let's look at proportions. So when we think about proportions, we want to think about the part to the whole. Okay, so let's do an example. If you can travel 120 kilometers on 6 liters of gas, how far can you drive on 8 liters of gas? Okay, so we want to make sure that we have it set up accordingly. So if we have gas on top here, we need to have gas on top over equals. And if I have 120 kilometers here, and I don't know how many kilometers here. Okay, so for 120 kilometers, I have 6 liters of gas. Okay, so if I want to know how much can I drive on 8 liters of gas, here I don't know how far I can drive. Okay, so this proportion is the same as this proportion. As long as I have kilometers with kilometers on top and gas with gas on the bottom, okay, it will also work as the previous example. So let's try both of them to check. When I want to use proportion, I cross multiply. So here I have 6 times x, which is equal to 120 times 8. Okay, so I'm going to bring it down, and 120 times 8 is 960. Okay, so then I need to divide both sides by 6. And here I get x is going to be equal to 160. Okay, so how far can you drive? I can drive 160 kilometers. Okay, let's check to see if this one works as well. So when I cross multiply over here, I get 6x. And I'm going to get the same thing here, 120 times 8. Okay, so as long as you have the same thing on the numerator in both and the same thing on the denominator in both, you're okay. Okay, so now I want to check to see, well, are these actual proportions? So there's one way that you can do it. First, you can look and see, is there something I can multiply the numerator by in the first one to get to the second one? So 4 times something equals 3. No, that one's not going to work. So here what you can do is you can cross multiply, okay? So I can do one side, 9 times 3 is equal to 4 times 7. So let's check. 27 equals 28. Nope, not true. So is this a proportion? No. Okay. The second one, here we have 9 times 9. So that's on one side. and 20 times 4 over here. So now I have 81 equals 80. Nope, not a proportion. Okay, so the other way that you might try it, that you can here, is I can see that 4 times 3 is 12, and 9 times 3 is 27. So in this case, I don't have to use cross multiplication because it works using this way. But let's say I didn't see it. Here I have 9 times 12 equals 27 times 4. Okay, so 9 times 12 is 108, and 27 times 4 is 108. Okay, so yes, double checking, it is a proportion. Okay, and then the last one, I see that 4 times 2 is going to give me 8. So if I do the same to the denominator, 9 times 2 is 18. So yes, these are in proportion. Okay, and then the last slide, here we're going to find the missing numbers to make the following proportions true. Okay, so the box here, just think of it as the letter X, we don't know what it is. Okay, so in the first one, I can actually see that really easily. I can just do 3 times 3, which is 9. Okay, so then in the second one, something times 3 is 21. Well, I know that 7 times 3 is 21. Okay, so here X I know is 7, but I'm going to double check it. Okay, so now I'm going to erase this and pretend like I'm not really sure. So I'm going to use cross multiply. So I'm going to take 9x and I'm going to set it equal to 21 times 3. Okay, so now I have 9x is equal to 63. And if I divide by 9 on both sides, I get x equals 7. Okay, so that means that 3/7 is equal to 9/21. Okay, all right, let's try the second one. So in this one I see that 4 times 2 will give me 8, but not 10. So this might be a decimal, so I'm going to have to use cross multiplication here. So 10 times x is equal to 5 times 4. Okay, so now I have 10x equals 20, and I'm going to divide 10 on both sides. Okay, so now I have x is equal to 2. All right, so some of you might have seen this before using the cross multiplication. Here I have 2/4 is equal to 5/10. Okay, you may have seen that 5 was half of 10 and 2 is half of 4, so these are in proportion. Okay, so here I had x equals 2, and that's it. Okay, let's move on to the next slide. Okay, let's look at rates. So Lewis drives 575 kilometers in 7 hours. How far can he drive in 3 hours? Okay, so I have kilometers and I have hours. So if I have kilometers on top, I want them to be on top for both. And I'm going to put my hours on the bottom. Okay, so I know that he can drive 595 kilometers in 7 hours. I also know that I don't know how far he can drive in 3 hours. Okay, so make sure that you have it set up with the same units on top and the same units on the bottom. From here we can cross multiply. So I'm going to get 7x equals 595 times 3. Okay, so 595 times 3 is 1785. Bring down the 7x. And I'm going to divide by 7 on both sides. So x is going to be equal to 255 kilometers. Okay, so let's check to make sure our answer makes sense. So if I can go about 600 kilometers in 7 hours, then I can go about 300 kilometers in 3 hours. And that's pretty close. It's actually less, it's 250 about, so that does make sense. All right, I'm going to erase here. Actually, I can't. So let's go ahead and try the next one. I'm going to scroll up a little bit. Okay, so John has 318 hay ice for 40 hours of work. That's how much he makes. What does he earn per hour? Okay, so I have hay ice and I have hours. So I know that he makes 318 hay ice in 40 hours. So I want to know how much is he going to make per hour, per 1 hour. Okay, so here is my x variable. I'm going to go ahead and cross multiply. 40 times x is going to be equal to 318 times 1, which is 318. Okay, here I need to divide both sides by 40. Okay, so that is going to be 795. Okay, so he makes $7.95 per hour. Okay, so I just want to think about that. That's about 8, and 8 times 40 is like 320. So yes, that's very close. He makes $7.95 per hour. Okay, so scale drawings are the scale measurement over the actual measurement. In part 2 of this lesson, we will talk about scale drawings. Whenever we have a scale drawing, we want to put the scale measurement over the actual measurement. Okay, scale drawings can be used for maps or blueprints. Okay, so if we want to find the scale on a map, the distance on a map from Toronto, Canada to Ottawa, Canada is 9.5 centimeters. Okay, so on the map, the distance is 9.5. The scale is 1 centimeter to 25 kilometers. Okay, so we want to make sure that if our scale is 1 centimeter to 25 kilometers, okay, that we set it up so that because I have centimeters on top here, I have them on top on the other side, and I have kilometers with kilometers. Okay, remember we want the scale on top and the actual distance on the bottom. Okay, so you can see that every proportion that I set up is accurate. So I do know that I went 9.5 centimeters on the map. So over here I'm going to put 9.5. And I'm going to use my scale to figure out how far that is in kilometers. So here I'm going to cross multiply. 1x, 1 times x, is equal to 25 times 9.5, which is 237.5. Okay, so 1x, we already have x alone, so our answer is 237.5 kilometers. Okay, so let's look back to see if our answer makes sense. 237 is about 9.5 times larger than 25, so it works. Okay, so using a scale drawing, try this one on your own, so pause the video and check back. Okay, let's see how you did. So the scale on the blueprint, so it will say it on the blueprint, like 1 inch equals 3 meters, okay? So I have my scale over my actual. Okay, so the map is 1 inch, and in real life that's going to be 3 meters. So now I want to find the actual length of the living room. I'm sorry, I know that the actual length of the living room is 18 3/4 meters. Okay, so I'm going to put that with my actual in my meters. So 18 3/4 meters. I'm going to go down here. Okay, so the question then says find the length of the living room on the blueprint. So on the scale, I'm not sure how many inches that is. So from this step, we're going to set up a proportion. So I'm going to cross multiply 3 times x equals 1 times 18 3/4. Okay? If you want to, you can change 3/4 to 0.75, or you can leave it as 3/4. Okay, so from here, I'm going to divide by 3 on both sides. When I divide by 3, I'm going to get x is equal to, if I do it over here, three times 6 is 18. I'm going to bring down the 7. So I bring up my decimal point. 3 times 2 is 6. And I have 15 left over, so 3 times 5 is 15. So 6.25 inches. Okay, so 6.25 inches on my map is going to be 18 3/4 meters in real life.